We're going to be looking at naming, classifying, and using angle properties. The way we have this set out is that today is going to be notes only. Tomorrow will be a work day for you in order to get caught up on maybe this homework as well as past homework. But that way you guys have a chance to make sure that you know the vocabulary and know what you're going to do. Some of this vocab you have already been exposed to in previous classes, but so this might be a little refresher and some things might be new to you, and that's okay. So a lot of vocab to start off with, just like our first section, we had a lot of vocab, but again, this is all setting us up for later units to make sure that we understand this vocabulary. So let's go ahead and get started. The first one, an acute angle. By definition, this is an angle that is between 0 and 90. This would be an acute angle. Let's say this is 60 degrees. A right angle is an angle that is exactly 90 degrees. Now you've probably seen this angle before. When you have a right angle, the thing that's different about this one is in the corner, they're going to give you a little box sometimes. And this just represents that it's perpendicular, aka 90. So this is also known as perpendicular. You might see me do this and I'll forget that I might not have showed it to you. So that's why I'm going to tell you now. You might see perpendicular as an upside down T, and that also represents 90 degrees. An obtuse angle is an angle that is between 90 and 180. Let's say this angle is 130 degrees. A straight angle is an angle that is exactly 180 degrees. So with this, it's going to be 180 degrees. This is also known as a line. Now, those are the four that I think that you probably have heard before. These next ones are probably new, and that's okay. Before we get to the examples, there's something else I got to talk to you guys about, and that's how to name an angle and talking about the different letterings for notation. I know in the first section we were very notation heavy. Same thing with angles, so we'll talk about how to name an angle after I finish this out. So adjacent angles are angles that share a side. So in this picture, I can see that this angle here, and this angle in pink, they have a common side. So notice that the green and the pink overlap there. This is what we call adjacent angles. So just something to note there is that they have to form, or if you're going to highlight, they have to have a common side. Vertical angles that form an X and are congruent, aka equal, but we'll talk about congruent in just a little bit. So we have an x, and we say that they're congruent because they're opposite of each other. So if I look at my highlighting here, it'd be this angle here and this angle here. Something that I like to call this a bow tie. I don't know why, but it kind of works for people because you can see that the bow tie here is formed. So they are opposite of each other, if that helps. And congruent angles that have the same measure. You will see this marked with an arc here. So like you'll have a marking here and you'll have a marking here. Those angles, those arcs represent that they're the same. If, for instance, one of those has a 1, and let's say this one had a 2, that means that those are two different measures. So they have to have the same marking. Right now, I want congruent, so I'm going to mark those as congruent, that they have the same measurement. So let's talk about the naming of angles first before we even get into the examples part. When you're looking at an angle, you are going to want to use 3 letters. Now, when we talk about a line, you could flip it and it could be line BA or it could be line AB. It didn't matter. But here's the difference with an angle. With an angle, this B, this is what we call our vertex. This letter has to be in the middle. So when I'm naming my angle, this angle here could be angle, and this is our notation, angle A, B, C, or angle C, B, A. So notice on both of those situations, the B, the vertex, was in the direct middle, and it has to be in the direct middle. Okay, so the outside letters, that doesn't matter, but the inside one has to be at that vertex. Okay, so that's going to help us in order to figure out these examples. So we're supposed to name 2 pairs of adjacent angles. I'm going to use highlighters. If you have different colored pens or if you need highlighters, I have a bunch of highlighters that are in, I've got a bunch of markers in that tower that you could use. But so let's talk about adjacent angles here. And we've got a lot of different angles in this picture. But let's do our adjacent ones first. So if I notice here, my pink and the green have an overlapping side. That overlapping side is where they both are touching, right? The green and the pink are both touching that ray CB. Okay? So 1 pair of adjacent angles, angle ACB and angle BCD. So notice on each of these, my vertex happens to be in the middle, which is the C. That's 1 set of adjacent angles. Now, if I do this green and the pink, then I also have another set of adjacent angles. So angle BCD and angle DCE. So notice on each one of these, I had a green and a pink. Now on vertical angles, they form that X and they're opposite of each other. So if I look at this, I already have a set that's highlighted, and that's both the green. So angle ACB and angle ECD. Those are both green, but then I also have the two pink. Angle ACE and angle BCD. Now in example 2, there's a lot of different angles going on there. So you could have a variety of answers, but we'll try to make this as easy as we can, okay? So I'm gonna go here with my pink. I'm gonna go ahead and match up its vertical angle with the pink because I think that's the easiest one to figure out because you're dealing with that X. It's kind of easier to highlight those together. And let's go with the green. Once again, I can see I made my X, and then I just highlighted the inside portion of that, and it's right next to the pink on both of them. So then I have my sets of vertical angles as well, where I can do a green and a pink. So for the adjacent, I'm going to go with the top green and the top pink, angle JGI, and angle IGH. So if you notice something with adjacent angles have two letters in common. So both of those had a G and an I. And then the third letter is different. And that's because we have that common side. So you have to have two letters that are the exact same. I'm going to go with the bottom green and the bottom pink. So angle KGL and angle LGM. Once again, I have two letters that are in common in order to have that common side. Green and pink. Now, let's go with our vertical. Again, we already talked about this, but it's the two greens together and the two pinks. So the greens, I've got JGI and angle LGM. And then angle IGH and angle KGL. And those are my two pinks. Okay, so again, it might benefit you to have a highlighter just so you can see everything that's going on there. Now, let's talk about these angles down here. Tell whether the angles are adjacent or vertical, and then find the value of X. So if I'm looking at this first one, do they form an X? No. So these are adjacent. Now there's something to note here about these angles. We then have to find the value of X. This is also going through and figuring out your classifications. Is this an acute angle, a right angle, an obtuse, or straight? Well, if I look here in the corner, I've got that box. This is a right angle, and a right angle equals 90 degrees. So we have 41 plus X equals 90. So I'm just going to solve this algebraically. When I do that, I subtract the 41 to the other side. The X drops down, my equal sign drops down, and I am left with my X value of 49. So your answer for this, for number 3, is the adjacent, and X equals 49. Let's talk about number 4. My two angles there, they form an X, it does form an X, but they're not opposite of each other. So these are adjacent. I can tell that together, these two angles form a line. because they form a line, I know that it adds up to 180 degrees. So this is a straight angle. Again, it doesn't ask you for that, but just kind of seeing how I'm setting up the algebra. How do I know how to set up the algebra? So looking at the algebraically, I'm plussing 109, so I'm going to subtract 109. I now am left with x equals 61. Number 5, they form that x and they are opposite of each other. So these angles are vertical. And we said earlier that vertical angles are congruent, which means that they're equal to each other. So I'm going to set this up as x plus 42 equals 2x plus 1. So now I'm just going to use my algebra. I'm going to get the x's on the same side. I am going to move the 1x to the right because I like dealing with a positive x value. You might like having the x always on the left. It just kind of depends. Drop down the 42. 2x minus 1x gives me x plus 1. And then I'm going to minus that 1. X equals 41. Now, this 41 does not necessarily mean that my angle is 41 degrees. This is just a value in place of. Where on number 3 and number 4, I have a degree mark on those because those are the actual angles. So just something to note there. On 6, these share a common side. They don't form that x. So we know that these are adjacent. They also form a line there, and a line is straight. So we know that it's going to add up to 180 degrees. Now my x's happen to be on the same side, so I'm going to go ahead and combine those on the same side. So it's going to be 1x plus 5x. It's going to be 6x. And algebraically, for my two-step equation, I'd subtract the 96. I have 6x plus 84. Divide by 6. And x equals 14. Again, I don't need the degree measure on this one because x is a value, it's not a total degree. So those are your examples. Your work time, your homework, we'll have a lot more of this and you'll probably have some questions. We'll go through some of it together, but this is just kind of a start. I know the last 3, the adjacent, the vertical, and the congruent angles are all new terms, but hopefully we can get all of that figured out. So that's our lesson for today.